associated with the table? Do you really know M? The answer is no. Do you have any idea how many M's you have for that particular shape? The answer is yes. So M is sort of described, but yet not. And now, do we have any idea how the electrons are moving? And the answer is no. But do we know how many electrons are total possible? Okay, so now I've got a question for you. What's the number one factor that makes energy level 7 have more energy than energy level number 1? What's the number one cause? It is size, but what causes you to be bigger? Thank you, Trey. It is the number of electrons. So if you have more electrons, you must have more energy levels. And if you have more energy, and you have more electrons, and that's what every single tiny electron carries. Energy. And every time you add an electron, you add more energy to your atom. Okay, so indirectly, what's the number one cause for change in size, change in energy? It really is the number of what? It's really the number of electrons. All right. Did I help you out a little bit? Okay, now I do need you to have out this one, and we're only going to be focusing on Oppolk, Pauling, and Hun's today, because we're going to learn how to do electron configurations. So we're also going to focus on these. We're going to focus on these as we go. Now, I don't know if it got passed down, but everybody should right now have a sheet that looks like this. And we're going to figure out, we're going to be using this paper the most, and I would like you to use the periodic table I gave you rather than the one on the board. And there's a reason for it. If you look at the periodic table I gave you, the first element down here is 57. And on your periodic table, the first one down here in F is also element number 57. On my periodic table up here on the board, the first elements up here are 58 and 90. There is a reason for that. And that is because there is discrepancy where D1 actually sits. Does D1 come before the F's or does D1 come after the F's? On the periodic table I gave you, it goes S, F, D1 for rows 6 and 7. If you look at the periodic table I gave you, you stop at barium, and lanthanide and actinide are down here. Is that correct? So it says it goes S, there is a break, you go down here to F, and then you go back to D. This periodic table says you go S, D1, F, back to D2. Now, don't worry about it. It's sort of like advanced mathematics. I'm not going to make you learn this. We're at 2 plus 2 is 4, and 2 minus 2 is 0. We don't know our times tables, our division tables. You've never heard of a square root. You've never heard of a radical. You're back in first grade, and you're learning to add and subtract, okay? So we're going to stick with a simplistic periodic table where we put the D's and the S's with the F stuck in the middle. Is that okay? So please make sure that if you're dealing with anything in these 2 rows, which periodic table are you going to have to look at? This one or the red one I gave you? Okay, just keep that in mind. And please, there's nothing wrong with this. You're just not there yet. Is everybody okay? We're still in the addition subtraction stage of electron configurations. All right, so we're still start simplistic. That's absolutely correct. Hey, let me give you actually. Okay, listen up. If you want to write notes on this, which like she did, that is fine. But for a test, what are you going to have to do then? Are you going to have to make a clean copy for a test? Because is she going to be allowed to use this on a test with notes on the back? However, do some students want to actually take notes on this piece of paper? If you do, feel free to do so, but when it comes time for a test, can you have anything written on here other than colored in and have the 1's and S's and P's and D's filled in? And the answer is no. So if you take notes on it, that's fine, but I just need to give you a clean one so you can make one for your test. All right? Absolutely no problem. Okay, we're going to go to this page here. Let me get... Ashton, I don't know where I sat them. I don't find you in 2 seconds. I'm going to wait to do it later, okay?
I'll look.
All right, I may not have stuck those extra ones.
Is it just this?
Just the one. Yep. Ashley. Lunch. Someone wants you. All right. Okay. Now. All right, I want you guys to look at this real quick. Now, the tool we're going to use for electron configurations is our periodic table. At the top of this piece of paper is also a tool. This is this. Ladies and gentlemen, this is confusing to me. This is how I learned it. And after I learned it by using the periodic table, I thought this was the dumbest thing I was ever shown in my entire life. So here's the reality of it. Why would I want to memorize something like this when I can just simply look at the periodic table and have all my answers? Today, do I need this to do electron configurations? The answer is no, because can I see it on a periodic table the moment I look at a periodic table? The answer is yes. So here's what I want you to do with this. I want you to get rid of it. I don't want you to use it, but I want you to realize that if you ever see that, that's for electron configurations. But you don't need it because will you be able to look at any periodic table and will you be able to see S, P, D, and F and the actual numbers that correspond with it when we get done with this unit? I guarantee you, I bet you 50% of you won't even need this today in the test. Because can you look at a periodic table and see this? And the answer is yes. The only reason why you might want it out is so you don't make a careless mistake. All right? All right, so what we're going to do is we're going to learn how to do our first electron configuration. And we're going to do the element potassium. I am going to turn the lights off so you guys can see what I'm doing up here a little bit better. And in order to do the element of potassium, guess what we have to do first? We have to find potassium on the periodic table. What element is potassium? Element which one? Now, we're going to assume for now that everybody is neutral. They're all atoms. There's no ions. So if you're neutral and you have 19 protons, how many electrons must I also have? So I have 19 electrons here. So what I'm going to do is I'm going to go to the periodic table that I colored, and I'm going to find element 19. This is where I have to go in reading my table. In reading my table, my goal is to get to 4s. Just like reading a book, you must start from the top and work yourself down. So if I'm working from the top, what is the only thing I see in row 1? 1s, and how many squares are labeled 1s? 2. So I'm going to take my paper and I'm going to write 1s, and that is an exponent of 2. So what did I have? These are labeled energy level 1, sublevel S, and how many squares are colored blue? 2. Now I'm going to move down. What do I see in row 2? Moving from left to right, what's the first thing I see? I see a 2s. And how many squares are colored 2s? How many squares are colored 2s? 2. From there, where do I go to? Go to where? 2p. And how many squares are colored 2p? 6. So now, so there is 2p6. Okay, now I've done row 1. I've done row 2. Now I'm going to go to row 3. What's the first thing I see in row 3? What do I see? 3s, and how many squares? How many squares? 2. From 3s, what do I go to? 3p, and how many squares? 6. Now, when I go to row 4, I am a 4s, but where is number 19? The first one. So do I need square number 2? So how many squares in 4s do I need? 1. So I just put a 1. And ladies and gentlemen, you just did an electron configuration. An electron configuration is just reading your table from left to right, from top to bottom, and you're counting your squares. Quick question, you can check this. What is 2 plus 2? Plus 6? Plus 2 plus 6 is? One more is? And did that give you your 19 electrons that potassium was supposed to have? The answer is yes. Now, let's talk about off-ball here. Off-ball. The off-ball principle states what? What are you supposed to do? If you don't know, cheat and look at your notes. What does off-ball say you're supposed to do? What does off-ball say you're supposed to do? All right, Parker?
An electron will occupy the lowest energy orbital that
Until it moves on to the next one, right?
Yeah.
So out of all of these, which is the lowest energy level? The 1s. And after it filled 1s, where did it go to next? And it ended where? So it went from least energy to the highest energy, and that's off-ball. So when you do an electron configuration, do you see off-ball? Yes or no? All right, let's try vanadium. Okay, where do you guys find vanadium on the periodic table? 23. So we gotta go to element number 23. So let's do it together. Reading your table from top to bottom. What is first? Now, you don't call it 1s squared. You just say 1s what? 2. So we have 1s2. Okay, go to your row 2. What do you have next? 2s2, and then after 2s2 is what? Following 2p6 is what? What? 3s2, and what follows 3s2? Okay, what follows 3p6? And we need all of those, so we need 4s2. Now, be careful. What follows 4s2? 3d what? 3d. Now, wait a minute. Vanadium is how many in the D? 3. So we need how many Ds? 3. Now, I'm going to go ahead and let you guys try cobalt on your own, but we're going to change Zr to HF. We're going to do hafnium instead of zirconium, okay? We're going to do hafnium instead. I want you to do number 4 as hafnium. But why don't you guys, we'll turn the lights on so I can see your work as I come around the room. But I'd like you to try cobalt, HF. Oh, it's right underneath it. All right, ladies and gentlemen, I want you to try cobalt on your own. If you get cobalt right, then you can try hafnium. All right?
Go ahead. Those are all the same color. I just accidentally did one color first. What color? If you want, you might just want to put that one else because you're confused. I would say that's probably the best thing to do.
You got it. Okay? Now, see, you have it done. I'm happy it's tricky though.
You said you moved
He's in row 6. Watch this here, he's in row 6. Yes. Yeah, you find it
And then
on here.
So
Yeah, you did it right, so that's where you're headed. You're correct. Good job. Let's see if you do the next part right. I'm watching you. No. Because what follows success? What follows success? You'll get to go down to this guy next. See, so far so good. Make sure this is like these messages.
You're acting like it's weird that I don't know.
Let me know once you got it. Put your hand out. Have her check it, okay?
Okay. Well,
So cobalt,
piece.
Okay, so far so good. Perfect. Okay, let me see if they have. You did. Good job. You remember the S. Good job. Good job. Yes, we're done. Correct? And you're on your way, that's your wrong, you're going to the wrong place. You're going to 72. Remember I said to change path?
Yeah, I know. I am lying.
I said to change it to HF. However, you did CR correct.
Girls, I need to see cobalt. Cobalt, please.
No, I know.
I want you to do what you did for me with cobalt. Cobalt is 2 strikes for 27. So you're going to start to write 1 as 2, then 2 as 2. Go all the way down till you get to that 27. So it's going to be 3D coming over 3. Okay?
So an HF D with the D over 5.
Actually, you have to go through Adam to get back to D. Okay, so that makes sense? So you're like 6 as 2. This, and then go back. Yep. Let me see, Paul. Okay, the only thing you're going to over, you have to go to 27.
So we have to count the individual items.
Right, so how far over are you? There you go, you got it right. Go ahead and try the next one.